So, we have significant figures is important. Tracking those lets us know the accuracy of the number that we're getting us a final answer. And we have to track those differently in each of the two different major processes that we're working with. Because I've got multiplication, which I'm actually going to cover first because it's a little bit easier. I find it a bit easier to track. And let me just check my field here. Addition. Now, I'm going to treat division as a special subcase of multiplication. You're multiplying by the inverse. And subtraction as just a special case of addition. You're adding the opposite of whatever it is we're dealing with. Now, I'll go through and I'll define how you track sig figs in each step. And then I'll give an example. To start with multiplication, in any case where I've got multiplication, the number of significant figures in the answer is a number equal to the fewest or least. We're going to go with fewest because we're dealing with integers here. Number equal to the fewest significant figures of the input number and again, this should be either fewest or least. Let's say with the fewest sig figs. Okay, as an example, hopefully that should be fair. Let me make this as an example so it'll hopefully look more straightforward. Suppose I've got .20 coulombs times 8.7432 meters per second times 4.000 meters divided by 0.0276 meters squared. That's vaguely like some type of things that we're going to run across later. Now, if I were to just toss my numbers into a calculator, remembering that calculators lie, then my calculator would give me a number of 1, 4, 6, 913.6736, let's see, coulombs per second. Never, the temptation to say, oh, I know what my final units are going to be. I will just ignore them as we go through. I will hit a couple of points this year where that will very, very often lead people to make major mistakes that they didn't have to make. You know, there's mistakes you're going to make as you go through here because you don't know the physics. To a level, that's at least to be expected. After all, if you know all the physics, why are you here right now? But what I hate seeing are accidental errors, losing accidental points. Now, let's see, so I've got meter squared, cancels out with those 2 meters, so I'm left with, yes, coulombs per second. Now, what's the level of accuracy that I have? Okay, 3.20 has 3 significant figures. This 0 is significant because it's to the right of a number that's significant and to the right of the decimal point. 8.7432, no zeros at all here, that's got 5 significant figures. 4.000 meters has 4 significant figures. These 3 zeros are each significant because they're to the right of the decimal point and to the right of the significant figure. And 0.0276 has 3 significant figures. So, the lowest number in all of this stuff is 3. Comes up twice. Nothing is lower than 3. Therefore, this final number has 3 significant digits to it. Now, the biggest mistake I see at this point is people look at it and go, okay, 1, 4, 6, chop, throw away, haha, I'm done. But you cannot do that. At that point, you must remember to look at the next digit and round. So, the correct answer to this would be 147,000 coulombs per second. But there are better ways to write that. The human mind, if I ask you to imagine in front of you a pile, oh look, here is an eraser. Imagine in front of you a pile of 17 erasers. Didn't seem like you did it. Give it a try. Okay, at least some of you did. Got a pile, that's probably pretty good. If I say, hey, imagine a pile of 147,000 erasers. At some point, your brain is just going to go big and quit on you. So, we can either write this in terms of scientific notation, 1.47 times 10 to the 1, 2, 3, 4, 5 coulombs per second. Notice that's 1.47 times 10 to the 5th. I know your calculator will tell you 1.47 E5, but that's not proper. It's not etiquette at the very least, and it's not, the reason why we have a this is the way that we fill things out is for clarity's sake, so that you don't have people doing things that seem best to themselves and confusing things later. Another way to do this is to go with the idea that, we will typically try and be able to imagine between like 1 and 1,000. So every 3 powers to 10, there will typically be a commonly used breakpoint. So this number, what our calculator tells us as 146,913.6736 coulombs per second, is actually, this number is wrong. The correct answer is 147,000 coulombs per second, which is better written as 1.47 times 10 to the fifth coulombs per second, or 147 kilocoulombs per second. I hope you can look at this and see why either one of these are cleaner ways to discuss this than simply writing it out as 147,000 each time. Certainly when we're doing the math with the significant figure, with the powers of 10, it's much better to do it like this. Now, okay, well, the rule often will look out long and clumsy because quite honestly, English is not the best language to be discussing this in. Calculus is the best language to be discussing this in, or at the very least, math. When we did this in math, I hope that made a lot more sense and came more clearly to you and actually retrofit the English, so now hopefully the English makes some sense. Now let us look at addition. The way the significant figures work in addition. I shall try to write as follows. The